Running PM2 start server.js name myapp works fine for a quick start. But what happens when you have environment variables to set? Multiple apps to manage? You want to specify the working directory? You need to set the number of instances for cluster mode? You could put all of this on the command line, PM2 start server.js name myapp cwd/home/ubuntu/myapp env node_env equals production imax. But command lines are not reproducible across servers, they're not version controlled, and they're easy to get wrong. This is the problem the ecosystem file solves. The ecosystem.config.js file is a JavaScript module that describes, declaratively and completely, how PM2 should run your application. Every configuration option, name, script path, working directory, environment variables, instances, log file paths, all in one file that can be committed to your repository. With an ecosystem file, starting your app on any server becomes a single command, PM2 start ecosystem.config.js. No flags to remember, no environment variables to set manually, no possibility of forgetting a configuration option. The file is the source of truth. The ecosystem file is also how you manage multiple applications from a single place. One ecosystem.config.js can define an API server, a worker process, and a scheduler, each with their own configuration. PM2 start ecosystem.config.js starts all of them at once. The ecosystem.config.js file is a standard common JS module that exports an object with an apps array. Each entry in the apps array describes one process PM2 should manage. At its most basic, module.exports equals apps name myapp script./server.js. But a production-ready ecosystem file has several more fields. Let's walk through the most important ones. Name is the display name for PM2 list. Use something descriptive that identifies the application. Script is the path to the entry point the file node.js should run. For a TypeScript project built to a dist directory, this would be a /dist/server.js. CWD is the working directory, the directory PM2 changes into before starting the process. This is critical. Without an explicit CWD, PM2 uses the directory you ran PM2 start from. If you later use PM2 startup and PM2 save, the process restores on boot using whatever CWD was set. If you ran PM2 start from your home directory, that's what gets saved. Instances is the number of processes to start. Set to max 4 cluster mode using all CPU cores, or a specific number. Exec_mode is either fork, default, single process, or cluster, multiple instances. env is an object containing environment variables to set for this process. Let me walk through a complete, production-ready ecosystem.config.js file that you can use as a template. At the top level, we have module.exports with an apps array. For our API server entry, name is API, script is server.js, CWD is /home/ubuntu/myapp, note the absolute path, we'll come back to why this matters. Instances is max 4 cluster mode. Exec_mode is cluster. The env_production object contains environment variables for production. Node_env is production. Port is 3000. Database_URL would be your database connection string. API_key would be any API key your app needs. For logging, we set out_file to /home/ubuntu/.pm2/log/api_out.log and error_file to /home/ubuntu/log/api_error.log. These are explicit log file paths. Without these, PM2 generates paths based on the app name, which works fine, but explicit paths make debugging easier. Log_date_format, YYYIMMDDHHMMSS adds timestamps to every log line, essential for debugging production incidents. Max_memory_restart, 500M tells PM2 to restart the process if it exceeds 500 megabytes of memory, a safety net against memory leaks that prevents a single app from consuming all available RAM. This file, committed to your repository and tracked in version control, is the complete description of how your application runs in production. Here is one of the most important lessons in this entire module, and it's something that trips up virtually every developer on their first production deployment. Relative paths in ecosystem.config.js will work when you run PM2 start manually from the right directory and silently fail after a reboot. Here's why. When you run PM2 start ecosystem.config.js from your home directory, the CWD in the config resolves relative to your home directory. Your app starts fine. You run PM2 startup and PM2 save to make it survive reboots. The server reboots. Systemd starts PM2. PM2 tries to restore your saved processes. But systemd starts PM2 from the file system root, not from your home directory. Suddenly, all your relative paths are resolving relative to / instead of /home/ubuntu. The script path doesn't exist. The working directory doesn't exist. PM2 marks the app as errored immediately. The fix is simple: always use absolute paths in ecosystem.config.js. Not /server.js, use /home/ubuntu/myapp/server.js. Not. Use /home/ubuntu. Not ./logs, use /home/ubuntu/myapp/logs. When is this most critical? The CWD field, the script field, and any paths you specify for out_file and error_file. If all of these are absolute, your configuration will work identically whether it's started manually or by systemd on boot. Write absolute paths. This is one of the few rules in PM2 configuration that has no exceptions. Environment variables are how you pass configuration to your application without hard-coding values in your source code. Database passwords, API keys, JWT secrets, these should never appear in your codebase. They should come from the environment. In ecosystem.config.js, you have two options for environment variables. The env field contains variables that are always set. The env_production field contains variables that are only set when you start with env production. You can have env_development, env_staging, and env_production, each with different values. Start with the production environment, PM2 start ecosystem.config.js env production. However, there's a security consideration: the ecosystem.config.js file itself contains your secrets. If it's committed to a public Git repository, those secrets are exposed. The correct approach for sensitive values is to use a .env file that is listed in .gitignore and read it into your Node.js process with a library like dotenv. For PM2 specifically, you can reference environment variables in your ecosystem file using process.env, database_URL, process.env.database_URL. Then set database_URL in your server's shell environment before starting PM2. This way the actual secret value never lives in a tracked file. A cleaner pattern: use PM2 ecosystem file for non-secret configuration, node_env, port, log_level, and use a .env file loaded by dotenv for secret values, database_URL, API_key, JWT_secret. With an ecosystem file, all your PM2 operations become simple and consistent. PM2 start ecosystem.config.js starts all apps defined in the file. PM2 start ecosystem.config.js env production starts them with the production environment variables. PM2 restart ecosystem.config.js restarts all apps. PM2 reload ecosystem.config.js performs zero downtime reload for all apps simultaneously. PM2 stop ecosystem.config.js stops all apps defined in the file without removing them. PM2 delete ecosystem.config.js removes all apps from PM2's managed process list. When you update your ecosystem.config.js, add a new environment variable, change the number of instances, you need to reload the configuration. PM2 reload ecosystem.config.js or PM2 restart ecosystem.config.js picks up the new configuration. For managing individual apps within a multi-app ecosystem file, PM2 reload API targets just the app named API. PM2 logs worker shows logs for just the worker app. In your deployment script, the typical sequence is git pull to get new code, npm install to update dependencies, PM2 reload ecosystem.config.js to apply the new code with zero downtime. If you changed environment variables in the ecosystem file, you need PM2 restart instead of PM2 reload, because environment variables aren't reread during a graceful reload. One of the most powerful aspects of the ecosystem file is its ability to manage multiple processes from a single configuration. Real applications often have several components: an API server, a background job processor, a scheduled task runner. In the apps array, you simply add multiple entries: apps, name, API, name, worker, name, scheduler. PM2 manages all three as a unified group. Each app can have completely different configurations. The API might run in cluster mode with 4 instances. The worker might run as a single fork process. The scheduler might run on a cron schedule using PM2's built-in cron feature. Cron_restart, 03**** restarts the process at 3 a.m. daily. Different apps can have different memory limits. The API might have max_memory_restart, 500 M, while a worker doing heavy processing might have max_memory_restart, 2G. With all apps in one ecosystem file, a single PM2 start ecosystem.config.js command brings up your entire application. And PM2 reload ecosystem.config.js updates everything at once. This is much cleaner than managing 5 separate PM2 start commands with different flags. For teams, this single file can be committed to the repository. Any developer or deployment pipeline that knows PM2 start ecosystem.config.js env production can bring up the full application stack with all the correct configuration. PM2's logging system captures all stout and std from your node.js processes and writes them to files. Without explicit configuration, PM2 creates log files in /.pm2/log/ with names based on your app's name. With explicit configuration, you control exactly where logs go. The out_file field specifies where stout goes, your application's normal output, console.log messages. The error_file field specifies where std goes, your application's error output, console.error messages. Set both to absolute paths. Log_date_format formats the timestamp prepended to each log line. YYYDMMDDHHMMSS gives you readable timestamps like June 5, 2024, 14:32 and 18 seconds. Without timestamps, diagnosing when something happened becomes impossible. Merge_logs, true combines the output from all cluster instances into a single log file instead of one log file per instance. For production, merged logs are much easier to search and analyze. Log_rotate is available through the PM2 log rotate module. Install it with PM2, install PM2 log rotate and configure it with PM2 set PM2 log rotate max_size 100 M. This compresses and rotates log files when they exceed 100 megabytes, preventing your disk from filling up with old logs. To view logs in real time, PM2 log shows all apps. PM2 logs API shows just the API app. PM2 logs lines 200 shows the last 200 lines before following. PM2 flush clears all log files if they've grown too large during debugging. Before deploying or restarting your production application with a new ecosystem.config.js, you should validate the configuration. PM2 ecosystem validate doesn't exist as a built-in command, but you can effectively validate by running node require./ecosystem.config.js. This loads the file as a node.js module and will fail with a syntax error if the file has any issues. It doesn't validate PM2 specific fields, but it catches the most common mistake, syntax errors in the JavaScript. For more thorough validation, you can run PM2 start ecosystem.config.js node-daemon on a test server to see PM2 start the app with your configuration without demonizing. The most important pre-deployment check, verify that all paths exist. cd/home/ubuntu/myapp ls-server.js confirms your script is there. ls/home/ubuntu/.pm2/log/ confirms the log directory exists and is writable. A deployment script that validates before applying changes, run the path checks, confirm node.js can parse the config, then run PM2 reload only if all checks pass. This prevents the scenario where a config typo causes all your apps to restart into an errored state during a deployment. After any PM2 reload or PM2 restart, immediately run PM2 list and PM2 logs to verify all apps came back online and are not reporting errors. Don't walk away from a deployment without confirming the process list shows online for all apps. A concrete question about the most critical aspect of the ecosystem file. Your ecosystem.config.js uses cwd./myapp and script./server.js. After running PM2 startup and PM2 save, you reboot the server. What happens to your app? Option A, the app starts normally because PM2 saved the configuration. No, PM2 saves the process list but uses whatever paths were in the ecosystem file. Relative paths are relative to where PM2 is started from, which is / when systemd starts it on boot. Option B, the app fails to start because systemd starts PM2 from / and relative paths resolve incorrectly. This is the correct answer. /myapp from /resolves to /myapp, which doesn't exist on your server. PM2 marks the app as errored immediately on boot. Option C, the app starts but with incorrect environment variables. The issue is path resolution, not environment variables. Option D, PM2 doesn't start on boot because you didn't enable the systemd service. This would be a different problem if PM2 startup and PM2 save were run correctly. Systemd will start PM2 on boot. The answer is B, absolute paths are mandatory. CWD must be /home/ubuntu/myapp. Script must be /home/ubuntu/myapp/server.js. No exceptions. When you see a PM2 app in errored state after a reboot with no obvious code issue, check the paths in your ecosystem file. Relative paths after a reboot is the most common cause.